Okay, guys, am I audible? So, shall we start the session? So, I hope you guys understood uh, the concepts of HCF and LCM. So, doubt in the fifth sum of the slide, sir. Okay, Palaniappan. So, he exactly knows which slide it is. Very good. Yes, so we look at it, Palaniappan. So, I'll just bring it up. I just take down the slides. Fifth slide. So, if you could tell me what the problem is, Palaniappan. Just tell me what the problem is, then we'll go over that. So, yes, sir. Okay, INR is able to hear me. Okay, guys. So see, some of you, I think it is Varsha. I remember Varsha's name, and I remember one more boy. I think it was INR or something. They asked me to give examples or real life applications of where we do HCF and LCM. Okay, so that is what I'm going to start this class with, and then we'll come to Palaniappan's doubt. Okay, so I'm going to give you real life examples of where we apply HCF and LCM. You have to see it, right? See, mathematics, guys, everything is applicable in real life. Okay, so that is why we have a math. We do addition because addition is applied in real life, right? You apply it in real life, day-to-day activities. We do subtraction, division, multiplication, everything is applicable. So similarly, any concept you take, we apply it. Okay, so but if people don't teach you what is a real life application, then it means they have not understood the concept well. Okay, so let us see where LCM and NCF are applied, and you will see that they are applied in strange places. Okay, so we look at how and where they are applied. Okay, so first thing I would say is, where is LCM and HCF applied? So we look at the Palaniappan's doubt. So sorry guys. So I have this handy here. Okay, so we'll look at Palaniappan's doubt. But before that, what I'd like you to do is, just a minute, please. So yeah, so LCM and HF, we look at where LCM is applied. Okay, so this is the situation, guys. The situation is, uh, I'd say it is. So the situation is something like this. Okay, you could say, just a minute. Okay. Okay, so the situation is something like this. Okay, let us say there are three bulbs. Okay, now there is a red colored bulb. Okay, a red light. Okay, there is a red light which blinks every 10 seconds. Okay, so once in every 10 seconds, what happens? It blinks. Okay, now we have a green light. Okay, now this one blinks every 20 seconds. Okay, so this green light blinks every 20 seconds. Now the third one is a blue light. So you can see the third one is a blue light, and this one blinks every 30 seconds. So every 30 seconds, what happens is the blue light blinks. Okay, now my question to you is, at what time? Okay, so just give your answers in the comment section. At what time will all the three lights blink together? At what time, okay, will all the three lights blink together? Okay, so this red light, if you have a look, it blinks every 10 seconds. Green light, it blinks every 20 seconds. Blue light blinks every 30 seconds. Okay, my question is, all these lights, okay, all these three lights, when will they blink together? Okay, so give me the answers, guys. Put it in the comment section. Okay, so most of you are saying 60, 60, 60. Yes. Now, what is that 60, guys? Can you tell me what that 60 is named? What is the name of 60? How do you call that 60? How do you call that 60? Exactly. Everybody says 60. Very good. Okay. So, 60 is the correct answer. Now, I want you to tell me, how do you name that 60? What is the name for the 60? Yes. Yes, Vignesh says it is HCF. It is not HCF, Vignesh. It is LCM, like how your other friends are giving it. Okay, it is LCM. Okay, so exactly correct, LCM. So yes, exactly, guys. So you can clearly see this this example that we took tells us, for this situation, if we have to find, now guys, you have to understand why it is 60 and why we are taking the LCM for this type of problem. Okay, you have to understand that. So what I'll do is, I'll first explain to you guys why we are doing this, why we are taking this 60. How did this 60 come about? Now, guys, you know this red light blinks at intervals of 10 seconds. So, if it first time if it blinks at 10 seconds, the next time it will blink at 20 seconds. The next time it will be 30. Then it will be 40. Then it will be 50, 60, 70, 80, 90, 100, and it goes on like this. Correct? Yes, you agree with me, right? Now, what happens is, the green light, it blinks every 20 seconds. Okay, so what happens is 20, 40, 60, 80, 100, 120, okay, and so on like this. Okay, here what I'll do is one small correction. I'll do this 110, 120, then we'll do this. Now, this blinks every 30 seconds. Okay, so this will start, first time that it blinks is at 30 seconds, then it will blink at 60, then at 90, then at 120, then at 150, then at 180, and so on and so forth. It goes on like this. So this is the time intervals, guys. So if you look at this, this is the time intervals at which the red light blinks. Okay, so 10 second, 10th second, 20th second, 30th second, 40th second. This is how it blinks. Now this is the time at which the green light blinks. So 20th second, 40th second, 60th second, 80th second. At these seconds it will blink. And this is the time at which, in seconds, okay, these are the times in seconds at which the blue light blinks. Okay, so the 30th, 60th, 90th. Now, as you can see, my question was, when does all these three lights blink together? That was my question. Now, if you look at this value, okay, so you have to find the common terms in all these three series. Yes, or you have to find the common term. Okay, because that is when the first time all the three lights meet. Correct. So if the first common term is 60. Okay, because here it is 60. Again, here you can see you have a 60. Here you have a 60. So the common terms, in terms of common terms, if you try to write, okay, so the common terms, the first common term is 60, then it is 120, then it is 180, then it is 240, then it is 300, and it will go on like this. These are the common terms. Okay, and we want the first time it meets. Okay, the first time they meet is the least common term. So we'll take this as the answer. Okay, because this is the first time they all meet. Do they meet only once? No, they meet a second time. So then they meet second time, it will be on 120 seconds. And they meet at the third time, it will be 180. And they meet at the fourth time, it will be 240. Okay, and it goes on like this. So this continues. Okay, but the important thing is, they look at the common terms. The first common term is 60. Here it is 60. Here it is 60. Here it is 60. So the first common term is 60. Okay, so that will be, or I should say 60 is the first number which is divisible by all these numbers, correct? 10, 20 and 30 divides what 60 is the first number divisible by all these numbers. Okay, so that is also one way of saying the LCM. Okay, you can call the LCM as the first number which is divisible by all these three numbers. So if you take 10, guys, you don't find 10 here and here. If you take 20, you don't find 20 in the third series. Okay, if you take 30, you don't find 30 in the second series. If you take 40, you don't find 40 in the third series. Take 50, you don't find it in second and third. But if you take 60, you find it in second and third. So 60 is the only common or the first common term between all the three series. So that is LCM. So during my explanation of LCM, you would have seen this is how I taught you LCM. Find the common terms or common multiples, okay, and among that you find the least. So that is why it is called least common multiples. Okay, so these are the common multiples. So these are the common multiples. So among them, the least one is this one. Okay, this is the least one. So this is why we call it as LCM. Now, one other thing that I want you guys to observe here is, now just look at the difference between this 60, guys. Just look at the difference between this and this. What is the difference? It is 60. Yes, correct. So similarly, look at the difference between this and this. What is the difference? It is 60. Okay. Again, look at the difference between this and this. The difference is 60. Okay. So it is always plus LCM. If you have to get the next number which is divisible by all these three numbers. Okay, the first number divisible by all these three numbers is the LCM. Okay, the first number divisible by all these three numbers, 10, 20, 30. Okay, so the first number that is divisible by all these three numbers is nothing but the LCM. Okay, but what about the second, third and the fourth numbers? To get the second number, you just add 60 to it. Okay, you add 60 to LCM. Okay, so what happens is you do LCM plus LCM. Okay, so you add LCM plus LCM will give you the second number. So after you got the second number, how do you get the third number? You add the LCM to this. Okay, so 120 plus 60. Okay, you add one. I just give you this. So initially we had the LCM to be 60, right guys? So our LCM was 60. To get the next number, what you do is you add the LCM. Okay, not 60, you have to add the LCM. But in this case, the LCM is 60. So that is why what do? We add 60. So what we get is 120, guys. To get the next number, what you should do is you should add 120 plus LCM. To get the next number which is divisible by all the three numbers, you should add 60. Okay, again to get the next number which is divisible by all the three numbers, it is again LCM, you add it. Okay, you add the LCM, you will get 240. Okay, and again I'll just do it one more time. Okay, so to get the next number, you will do 240 plus LCM 60, which will give you 300. Now look at what I have done. Okay, to see this is 60 is the first number which is divisible by all the three numbers, guys. So you take all 10, 20, 30, it can divide 60. So that is the reason why we call 60 as the LCM, because this is the first number which is divisible by all the three numbers. Now what if the question asks you to find the second, third and the fourth number? What do? You just add the LCM to it. Okay, so to get the second number, add the LCM to the first number. To get the third number, add the LCM to the second number. Okay, to get the fourth number, add the LCM to the third number. Now what if they ask you to find the ninth number? Should you go like 1, 2, 3, 4, 5 up until 9? No, right? If you just have a look at this, to get the second number, okay, It is just sufficient that you multiply 2 into LCM. Yes, 2 into LCM will give you the second number. Then what? How do I get the third number? 3 into LCM. This will give me the third number, right? So third number is 180. So if we have to get the 10th number, I just do 10 into LCM. Okay, so 10 into LCM will give me 600. So my 10th number is 600. So this way you can easily find the nth number. Okay, you don't need to like do this step. Okay, so this is just for your understanding purpose that I've given it. Okay, so I hope you guys understand where LCM is applied. So LCM is applied in situations like this. Okay, so I want to get into, and HCF also. I'll talk about HCF, guys. So we'll also look at some HCF. If I give you an example, if I have to give you an example for HCF, so let us assume there is a uh, so okay, so this is how it is. Okay, we have a rectangular window. Okay, we have a rectangular window. Okay, now this, just watch this carefully. The length of this side, okay guys, is 12 meters. Okay, so this is 12 meters. So I'll write it as 12 meters. Now the breadth is so can we keep it as 8? So we'll keep it as 8. The breadth is 8 meters. Okay, now the length is 12 meters, the breadth is 8 meters. Now they are going to fix some grills. Okay, so the grills goes like this. By grills, what I mean is, guys, it is like this. Okay, so this is 1, 2. Yes, you understand this. These are the grills. In Windows, they'll keep grills like this, right? So this is a very good example of HCF. So pay close attention to the question. Okay, they're going to place grills like this, guys. So like this. Okay, now how many grills? Okay, how many grills should they place in such a way? So see, when you, it is not only this side, you also have to go this way. Okay, so this also is important. Okay, now my question is this. Okay, you have to find how many. Okay, so this is just a rough diagram. Okay, not the exact diagram. See, if you have to get this, guys, if you have to get this area, okay, the area of this square. Okay, so this is a square actually. So what you have here is a square. If you have to have this square, okay, to be equal, the area of this square to be equal, how many grills will you have? Okay, so how many grills will you have this side, and how many grills will you have this side? Okay, that obviously you must have equal number of grills, right, both here and here. Okay, so if you have to have this area to be the same, okay, how many grills will you have? Okay, so this is a very deep question. What I want you to do is to think about this question. Okay, I'll repeat it one more time. Okay, so that you understand this question and think about it. This I'll give you the explanation for this in the next session. Okay, because I want you to think about it. Okay, just think about, the question is this. Okay, this is a window and you want grills. Okay, you want grills, and you have to tell me, then see the number of grills that you must have here on this and here will be equal, because this is a square, right? So you know, when it is a square, this part is a square. Okay, so the number of grills you will have this way and this way will be equal. Okay, now my point is, how many grills should you have, so that this area is equal. Okay, this area should be equal, so there should not be any change in this area. Okay, so like that, how many grills can you have? Okay, so this is one example. Okay, just think about it. But right now what I want you guys to do is to understand HCF. I'm going to give you an example for HCF. Okay, now there is a okay, let's take a scale. So this is a scale, so assume this to be a scale. Okay, this is a scale, this is a scale, and this is one more scale. Okay, now guys, the length of this scale and this scale and this scale is given. Okay, so the length of this scale is 150 meters, centimeters, sorry. The length of this scale is 225 centimeters, and the length of this scale is 300 centimeters. Okay, now my question to you is, okay, what is the largest scale that I can use? I have to use only one single scale. Okay, so let's take that scale to be this. Okay, this is that scale. Okay, so my question is, what will be the length of this scale if I have to use only this scale to measure all these three scales? Okay, to measure all these three scales, I have to use only this scale alone. Okay, this is the only scale that I can use. Okay, so what should be the maximum length of this scale? That is my question. Okay, so what should be the maximum length of this scale? So I want you guys to give the answers in the comment section. Okay, so this is my question, guys. We have three scales, or I'll just mark it as scale 1, scale 2, scale 3. So this is scale 1, scale 2, this is scale 3. Okay, now this is the measuring scale. Okay, so this is the measuring scale. So what I want you guys to tell me is, how long should be the measuring scale? What is the largest size that the measuring scale should be to measure all these three scales, scale 1, scale 2, scale 3? To measure all these three scales, what is the largest measuring size that this scale can take? Okay, see, if this measuring scale was, let us say, was one centimeter. Okay, if this was 1 centimeter, surely it can measure all the scales, the three scales, right? Yes, scale 1, scale 2, scale 3. But that is not what I want. I want the largest centimeters, or the highest length that this scale can be, so that it will be able to measure all the three scales. Okay, so it should be able to measure this scale, it should be able to measure this scale, and this should be able to measure this scale. Okay, I hope you got the question, and I'm expecting some answers, guys. See, we already got the answer. Okay, 75, 75, 75. Exactly, guys. So when you say 75, yes, correct. Yes, 75, yes. And may I ask you guys to tell me, name the 75, like the last time you named it. How do you name 75? How do you name 75? HCF, exactly. Okay, so Aishwarya says it's HCF of 150, 225 and 300. Exactly, guys. So this is HCF. So this is exactly Hepzibah, Sharon, Mugnesh, Rajesh, Gokulnath, Amarnath. They all say HCF. Very good. Yes. See, this is HCF. So this is what we are looking at. Okay. So this is how you guys have to understand. These are applications of HCF. Okay. And I'll give you the explanation for this question, the first one at the beginning. Okay, I'll give you the explanation. Here, the reason is, see, when you take 75 centimeters, okay, guys. So if you take 75 centimeters as the length, okay. Now what happens is, using this 75 centimeters, you can measure 150 centimeters. There is no problem, right? Similarly, using this 75 centimeters, you can measure 225, because 75 3 times is 225, so you can measure it. Okay, and using the 75 centimeter scale, you can also measure 300 centimeters. Okay, so 75 is the HCF of 150, 225 and 300 centimeters. So problems like this, we use HCF. So once you understand this problem, this measuring problem, you will also understand the problem that I gave you in the uh, lecture, okay, on the slides. You will also see that. Now you will also understand that. Okay, now see, if you let's continue, guys. So what we'll do is we'll continue with problems, and I'll give you the explanation for this problem in the next class. Okay, I want you guys to think about this. Okay, just think about it, because only with thinking you'll understand it well. Okay, so we'll take it that way. And I want to look at somebody's question. Mobile unit norm tty nomni. Okay, Sasikum Santkumar. Okay, so we have a question. Okay, Palanipan asks, fifth sum is what is the largest 4 digit and the smallest 3 digit number divisible by 6, 5, 21 and 24. Okay, so that is what Palanipan Rao. So we look at this question. Okay, so what Palanipan is asking us is, he is asking us, I guess it is this question. Yes, so this is the question that he's asking, guys. So let's see what is being done. So this is the question: what are the largest 4 digit and smallest 3 digit numbers divisible by 6, 5, 21 and 24? Now what we'll do is, so I'm going to take and write down what is given. So what are the largest 4 digit and smallest 3 digit numbers divisible by these numbers? So the given numbers are 6, 5, 50, sorry, 6, 15, it's 15, right? 15, and then it is 21 and 24. See, first, before you find the largest 4 digit and 3 digit numbers, you find the first number divisible by all these numbers. Okay, what is the first number that is divisible by all these 4 numbers? Okay, now we just now spoke about it. Okay, before the HCF session, I mean, before the HCF teaching, I gave you this. Okay, I told you how to find the least number divisible by all these numbers. The least number divisible by all these numbers, guys, is nothing but what? It is nothing but the LCM of these numbers. Yes, the LCM of 6, 15, 21, 24. Okay, so first thing that I want you guys to do is to find the LCM, guys. Find the LCM of it. Okay, you need not put it in the comment section, but I want you guys to find the LCM of 61, 6, 15, 21 and 24. You need not, like I told you, you need not put it in the comment section, but just find the LCM, guys, and tell me what the answer is, or put it in the comment section. Okay, you cannot speak, right? So put it in the comment section. Now, how much did you all get? Yes, exactly, 840. Okay, Aishwarya, you are right. Aishwarya, Tulasi, Rajesh, Shalini, you guys are right. It is 840, guys. See, I would say it is 840. Okay, so LCM of all these things is 840. Okay, now what happens here is, you just take 840. Now the question is, we not just seen the question. So this is the question: what are the largest 4 digit and the smallest 3 digit numbers? Okay, now what is the smallest 3 digit number? I told you this is the first number. Okay, so this number is the first number divisible by all the four numbers, correct? 840 is the first number divisible by all the four numbers. So the smallest three digit number should be what? It should be 840. Your smallest three digit number should be 840. Now guys, I also told you to get other numbers. Okay, to get other numbers, what do you do? Do you remember it? What did we do? We did 2 into LCM, 3 into LCM, like that we did, right? Yes, we also want the largest 4 digit number. Okay, so this is 840, so we should go somewhere close to 10 into LCM. Yes, not exactly, but it could be 10 into LCM. Okay, so if you do 10 into LCM, what happens is, so 10 into LCM will give me 8,400, correct? So we are getting close to the uh, end of four digits, because what is the end of four digits? It is four nines, right? So you see it is not this. Okay, if you do 11 into LCM, what do you get, guys? You will get 9240. Okay guys, okay, so 9240. So 9240, if you add 840 to it, what happens is, or if you do 12 into LCM, it will go beyond 10,000. So it will become a 5 digit number. So you can say that the 3 digit number is 4 digit, largest 4 digit number is 9240. Okay, and the smallest 3 digit number is 840. So 9240 and 840 are the correct answers. Okay, so this is what so you will have to understand this. You have to understand that the least number that you can find is the LCM of all the given numbers. Okay, then how do you find the next numbers? You just have to do 2 into LCM to get the next number, 3 into LCM to get the third next number, 4 into LCM, 5 into LCM. Using that, you can easily maneuver between the answer that you want. Okay, so what we'll do is, case we'll look at the answers for this. So the answer is, so you can see the first number divisible by all these are 840. Okay, so like I told you, the smallest 3 digit number will be 840. Okay, so the largest 4 digit number will be 840 into 10. So see, that is what I've done. Plus 840. I'm going very close to 9,000. Okay, so going very close to 9,000 means 840 into 10 is very simple to calculate, right? So that is why it is 8,400, which is 9240. Now if you add 9240 and 840, it will become a 5 digit number. So the largest 4 digit number is nothing but 9240. So the smallest 3 digit number is nothing but it is 840. Okay, so did Palaniyappan get his thing answered? Yes. So I hope Palaniyappan got his question answered, guys. We'll have to look at a few things which we did not cover the last time. Okay, so I stopped here. If you remember this, I stopped here actually. Okay, so I guys see HCF. How did you find? I gave a shortcut up for finding HCF of more than two numbers, because here we have more than two numbers, right? So if you have pay close attention here, you can see you have three numbers. Okay, so the way you find the HCF is, see, 1 minute please. Yes, so the way you find the HCF is different. Okay, when you have two numbers, just take the common term outside. Okay, if you remember that method, you can use that. But when you have more than two numbers, what you do is subtract them. Okay, so how do you subtract them? You can do 455 minus 300, you get 155. 575 minus 455, 575 minus 300. So you just subtract these numbers. When you subtract these numbers, you make sure you take these two numbers and subtract it. Okay, then what do you do? Take these two numbers and subtract it. Then what do you do? Take this number and this number and subtract it. Okay, so likewise, if you subtract it that way, what will happen is you will get three values. Out of those three values, take the smallest value. Okay, Now take the smallest value and see if this 120 can divide all the three values. Okay, this 120 must divide all the three values. If suppose this 120 divides all the three values, guys, then you can say this 120 is your HCF. Okay, so that is what I was talking about in the previous class. So this is where we ended the session. Okay, so if this 120 can divide all the three values, it means this 120 is the HCF of these three values. But as you can see, guys, 120 cannot divide all these values. So what we did was, the next step that we did was, yes, we saw if it is 120. We wrote 120. We prime factorized 120. Okay, so by prime factorizing, we make things easy. Whenever you make things easy, guys, see, you are not seeing 120 as 120. You are seeing 120 as what? You are seeing it as 2 power 4 into 3 into 5. So this is how you are seeing 120. Okay. So 120 is no longer 120, it is 2 power 4 into 3 into 5. By splitting up like this, now you can see what is getting divided and what is not getting divided. Okay. By that, what I mean is, guys, by splitting up like this, you can say if 455 is divisible by which of these numbers. You can say that. You can also say 300 is divisible by which of these numbers. 575 is divisible by which of these numbers. This is going to help you. Okay, so I'll tell you. So just stay with me. I'll tell you what it means. Okay. Now, I told you if all these numbers are divisible by 120, it means the HCF is 120. That is not the case. So we'll have to see which part of the number divides all the three numbers. Okay, which part of the number divides all the three numbers. So this is the most important part that you can do. Okay, because the part of the number or part of 120 which divides all the three numbers is your HCF. Yes, yes. Previously, what did I tell you? If 120 divides all the three numbers, that is your HCF. That is not happening. 455 is not divisible by 120. Okay, that is not happening. So the part of the number, okay, so that is why we are splitting up 120. We are splitting up 120 because 120 is not dividing all the numbers. So we will see what is dividing all the numbers. So for that, split it up. So the part of the number which is 120, which divides, it could be just 2 into 3 which divides it, or 3 into 5, or just 5, or just 3, or 8, or 16. We'll see what divides it. Okay, but the part of the number which, or I should say part of 120 which divides 455, 300 and 575 is your HCF. Okay, the finding this way is very easy. Now let us see. Now guys, the first thing that I want you guys to see is, look at these numbers. Okay, 455, okay, this number and this number 575. These numbers are what I call as odd numbers, correct? Yes, 455 and 575 are what I call as odd numbers. Guys, now tell me, will you have a 2 in an odd number? Yes, will you have a 2 in an odd number? Definitely not, right? So surely 2 won't divide 575 and 455, correct? And not only that, it is not only 2, 4 also won't divide 455 and 575. 8 also won't divide 455 and 575. 16 also won't divide 455 and 575 because all these 2, 4, 6 and 8 have 2's in them. But this 2 odd numbers don't have 2's in them. Okay, so you can clearly take this, okay, and say this 16 will never divide all the three numbers. Okay, so it is left to the final 3 and 5. Okay, so we are going to check only 3 and 5 and see if it can divide 455 and 375 and then make a final decision about it. Now, so we are just concerned about 3 and 5 because we know that a 2 cannot divide an odd number. So all these 2's are useless for us. So the only possibility is for us to see if 3 can divide everything. Now just look at this first number, guys. Just look at this first number. What is the sum of all these digits? 5 plus 5 plus 4 is 14. Now Is this 14 divisible by 3? No, right? So at this point itself, you can stop checking and then declare that 5 is the HCF. Why did I do that? Okay, so I can, at this point, I stop checking and then I am declaring that 5 is the HCF. Okay, for some of you, if you do not understand why I did that, because see, this 3 cannot divide 455. If 3 cannot divide 455, what I am doing is I am left with only 5. Now I look at this. Now is this divisible by 5? Surely, correct? Is this divisible by 5? Surely. Is this divisible by 5? Surely. Right? So there I have my HCF. Okay. So this is may seem like a long process, but once you practice, this will give you answers very quickly. And one more thing is, it will give you answers accurately. You won't make mistakes because all these numbers are small numbers, guys. 2, 3, 5. All these are small numbers. You're not dealing with major numbers. Okay, we are not asking you to divide 455 by 575 or something like that, so which you will do. So make sure you follow this method. Okay, so this is going to give you answers very easily, quickly. Okay, now what I'll do is we'll move on and see what else is happening here. So I've given you another example. So what I did is I just find the differences and then take the smallest difference. So if I take the smallest difference, guys, what will happen is I'll get this. So this is the smallest difference, 187. Now 187 is, can this 187 divide all the three numbers? Now you have to look at clues. Okay, now if you have to look at this number 1190, take off that 0. Okay, because you can multiply it by 10 later. Okay, so divide it by 10 now. Okay, so can 187 divide 119? No, right? 187 cannot divide 119. It is not possible. So 187 definitely is not the HCF. So this is how you reason it out and find answers very quickly. Okay, so you say, so this comes with practice, guys. Like, sir, you know all these things, so you might be able to do it. How can we do it? You have to practice with problems. Okay, practice with problems, you will be able to do it. Okay, it is not at all difficult. You see 1190, you take 187. Okay, and you can clearly see 119 is not divisible by 187. So definitely 1190 is not divisible by 187. Okay, so if 187 must divide all the three numbers for it to become the HCF, right? So 187 is not becoming the HCF. So what do? We move on. Okay, the next step is split it up and write it. Okay, so before we do this, okay, don't look at the third question, we'll do it, but concentrate on the second question, guys. If you look at the second one, you see 1190 is divisible by 187. Okay, so what happens is it is not. So what do? I split it up and write it in terms of prime factors. What is 187? It is 17 into 11, and you can clearly see both are prime numbers. Okay, so I split it up and write it in terms of prime factors. Now what I do is, guys, now you know 187 is 17 into 11. Okay, now what should I check? I should check if 17 can divide any of these numbers. Okay, if 17 can divide not any of these numbers, 17 must divide all the numbers, correct? So what I do is I'll take 17 and try to divide all the numbers. Okay, now how do I do it? Okay. Now you guys know 17 one times, you just do it for one number that you feel is, take 17 and try to divide it for 765. 17 2 times is 34, right? 17 3 times is 68. Okay, so what does it, sorry, 17 4 times is 68. So what does it mean? It means 17 can divide 68, or I can also say 17 can divide 680, correct? So I can say 17 can divide 68, not only 68, 17 can divide 680. Now how much is this far away from 680? This is from 680. Okay, if you calculate it, it is 85, I guess, correct? Yes. So if it is 680, guys, this is actually 85. right? So 85, now can 17 divide 85? Yes, it can divide 85. Exactly, it can divide 85. Okay, uh, that is the reason we do this. Okay, if you know something about 119, you will say that 17. Okay, how many times will give you one? Will it give you 119? Can 17 divide 119? 17 how many times? 17 4 times is 68. 17 5 times is 85. 17 6 times is 102. 17 7 times is 119. Okay. So you're seeing that this is also divisible by 17. This is also divisible by 17. So you are left with 952. We'll try and check if 952 is divisible by 17. Guys, you know that 85 is divisible by 17. Okay, so you're left with 10. Your remainder is 10. Okay, so here 85 here, 85 is divisible by 75. So the remainder is 10. The club that 10 with this 2, you will get 102. You know 102 is divisible by 17. So this is also divisible by 17. So you can see all these numbers are divisible by 17. So what is the HCF? You don't need to check for 11 at all, okay, because you know 17 into 11 is not the HCF, right? You very well know 17 into 11 is not the HCF. So if 17 is dividing all these numbers, it means 17 is the HCF. Okay, um, so what I'll do is take you to this, guys. So did you guys understand how you got 17 as the HCF? Okay, so I'll just give you one last thing before we go to the attendance. Okay, so I'll just give you this example, okay, so that you see this example and understand this also. Okay, so the third one, again they've given three numbers. Okay, now here you can see, guys, 9, what is the least number that you can see? The least number that you can see here is 92. Okay, so you have to check if 92 can divide all these numbers. First thing is, if you look at this number, 92 is not dividing it, correct? Because 92 into 10 is 920. Okay, so 92 will divide 920, not 943. So 92 was not dividing. So because 92 is not dividing, what do? You split it up like this. Okay, and I split up 92. And especially I'm taking out 2's because, guys, just look at this. The importance of taking out 2's is, when you take 2's like this, you can clearly see there are two 2's and there is an odd number. Okay, here also there is an odd number, here also there is an odd number. So obviously these two 2's won't divide this odd number, so you can eliminate these two 2's. So finally you are left with only 23. Okay, so I guess if this 23 can divide these three numbers, that is the HCF. If it doesn't divide these three numbers, then what is the HCF? 1 is the HCF, right? Yes, if 23 cannot divide all these three numbers, then 1 is the HCF. Okay, now it is easy. See, 23, how do you go about dividing these large numbers with 23? Again, guys, bring it close to these numbers. Okay, see, you don't know 23, you know 23, you don't need to worry about going far. Now the 23 2 times is what, guys? 46, right? 23 2 times is 46. What is 46 2 times? It is 92. So you can clearly see 23 will divide 92. Not only 92, it will also divide 920. Correct? Yes. So 23 will divide 920. Not only 920, guys. So this is how you go. Okay. So just a minute, guys. See here, you do 23 into 4. This will give you 92. Okay. So this is not only the 92. 23 into, then what is 40? 23 into 40 will give me 920. Okay. Now you see 943. How did that come about? Plus 23. This will give me 943. Okay. So this is how you see that 943 is clearly divisible by 23. Not only that, 92 is also clearly divisible by 23. Okay. So you can take this a step further, guys. See, 23 into 5. Okay. So how do you do this? So These are shortcut ways you can use. 23 into 5, guys, you know very well, is 115, right? Correct? Because you just have to add 92 and 23. You will get this 115, right? So this is 23 into 5. Now what does 23 into 50 is? It is 1150. Okay. Now in 1150, if you subtract 23, okay, what do you get? From 1150, you could keep subtracting 23s, okay? But anyway, you 1 minute, guys. Yes. So if you subtract, what is 23? 23, you will get 115. Yes. Now if you subtract 115 from 1150, you will get 1035. Yes, exactly. Yes. So this is how you find it. This is how you find if a number is divisible or not. Okay. So move around. You know that 1150 is here. Okay. You have to find 1035, right, guys? So 1150, 1035. You have to see if it is possible for you to get it. Okay, 1150 minus 115 will give you 1035. So definitely 1035 is also divisible by 23. So our answer here is 23. Okay, our HCF is 23. Okay, so what we'll do is we'll do the attendance, guys. If you still have any doubts in this, you can ask. Link not open, sir. Yes, attendance. We'll do the attendance now. Okay, so right now they'll open the link now. And then we'll continue. Okay, we'll just, yes, it'll open now, guys. They'll open it now. If you understood all this, we just have a 5 minutes more. Okay, 5 minutes content remaining. Okay. So now the link will work. Okay, open it. Now open it again. Open it again, guys. Open the latest link that they posted. See, I just opened it for you, so it is opening. Okay, so the link is closed, guys. So I hope everybody gave your attendance. So just 5 more minutes. Give me 5 more minutes, guys. I'll just complete this LCM part. Okay. So we've seen the HCF, how to do HCF, but I want you guys to understand how to do LCM also in a shortcut, using the shortcut. Okay. Now LCM of, let's say we have more than 2 numbers. Here we have 4 numbers. Okay. Now in LCM, the approach is different. Okay, I'll tell you what the approach is. See, we've been given four numbers here. So you can see that we have four numbers which are given at this point. Okay, so these are the four numbers, guys. Okay, now you have to find the LCM. The first thing that you do is, okay, so we have four examples. Okay, first thing that you do is, guys, you take the largest number. Okay, the largest number here is this one. Okay, so this is the largest number here, right? So take the largest number and try to see if any of the small numbers can divide it. Okay, any of the small numbers can divide the largest number. Okay, so if take 1044 and try to see if 261 can divide it, and surely it can divide. Okay, so if that is the case, what you do is, guys, you club 1044 and 261. Okay, so you make the two numbers into one. Okay, so that is the thing that you do. Okay, so now what did I do? I made 1044 and 261 into one number. Now what you have is 1044 only. Okay, so now it is no longer two numbers. It has become what? It has become a single number. Okay, so it has become a single number because 261 can divide 1044. Okay, so you repeat this process again and again, and the final number you end up with is the LCM. That is how simple it is. Okay, you repeat this process again and again, and the final number you are left with is the LCM. So look at how carefully I am doing it. So look carefully. So what I did is took the largest number and divided by a smaller number. If it was divisible, then I clubbed it. Okay, now you don't see 261 anymore, right? 261 has vanished because 261 can divide 1044. Because 261 can divide 1044, 261 vanishes. Okay, where does it vanish? It is not vanishing, guys. Actually, what is happening is 261 is already a part of 1044, right? Yes, 26 because only then 261 can divide 1044. Only you have, if you have a 261 in the product of 1044, okay, you can divide 1044 by 261. Correct? I can write, if I want to show it correctly, 261 into 4. Now what is this, guys? What do you think is 261 into 4? That is 1044. Okay, so as I told you, you can see you have a 261 in 1044. Okay, that is why you are able to divide 1044 by 261. Okay, so 261 is already a part of 1044. So you don't need, when you are finding LCM, you don't need to have it separately. Okay, so that is why we are clubbing. This is the reason for clubbing both of the numbers. Okay, now what I do is, now I have 1044. I take the 87. I take the next number 87. This is the next number, right? So I take the next number 87 and then divide it. And surely 87 will divide 1044. So what I do is I club it both and then I do it like this. And if some of you didn't know it, 261 is nothing but 87 into 3. Okay, so 87 into 3, 87 into 3 is 261, guys. So that is why it is able to divide it. Not only that, 1044 is also divisible by 29. So what happens is, because look at these numbers, 261, 87, 29, everything divides 1044. So everything is part of 1044 already. Okay, so your final answer is 1044 here. Okay, so you don't need to do much of stuff. So you have to just look at the large number and see if the other smaller numbers are able to divide it. If able to divide it, you just club it. If it is not able to divide it, I'll tell you what to do. Okay, but here you can see all the three numbers are able to divide 1044. So 1044 is the LCM. Okay, that is how simple it is. Okay, but if it is not able to divide it, okay, I'll tell you what to do in that case. Okay, now guys, take 1044 and 319. Okay, you don't have 261, you have 319. Okay, now look at what happens. Surely 1044 will not divide 319. I mean 1044 is not divisible by 319. Okay, So you cannot club it. So what did I do? I kept it as it is. Okay, so 1044 and 319 remain as it is. Now it doesn't mean we stop there. We try to do other combinations. Okay, take 1044 and divide it by 87 and 29. You know very well 1044 is divisible by 87 and 29. So you can club it as one number 1044. Right now we just, so this and this has vanished. Okay, so what has vanished is these two numbers has vanished. Okay, it has gone and merged with 1044. That is how you should look at it. So 29 and 87 has merged with 1044. So right now what you are left with is, guys, is these two numbers. So because 319 cannot divide 1044, look at what I am doing very closely. Okay, this is what I am doing. I am writing 1044 as its in its prime factorized form. Okay, so 1044 written in its prime factorized form, and also 319 written in its prime factorized form. The reason why I write it like this is, guys, the reason is very simple. Okay, see, why is 319, okay, why is 319 not able to divide 1044? Okay, if you looked at my previous lectures, you would understand this. The reason why 319 is not able to divide 1044 is, guys, see, 319 is made up of 29 and 11. Okay, see, you have a 29 here. Okay, but where is the 11? Where is the 11 in 1044? That is my question. Do you have 11 in 1044? See, try however you may. 2 into 2 is 4, 2 into 3 is 6, 2 and 3 into 3 is 9. Okay, 9 into 2 is 18. You get numbers which are not 11. Okay, so let us just say it like that and leave it. Okay, so you don't get 11. See, this is the reason, because you don't have 11 in 1044, you cannot divide 319 by 1044. So what should you do to make sure that this number here is divisible by 319? How do you make 1044 divisible by 319? You multiply by 11. Yes, multiply 1044 by 11. What will happen is 1044 will turn itself into a number which is divisible by 319. Because when you multiply it by 11 like this, I'll show you this. Now when you multiply it by 11, you will get 11,484. Now this is divisible by 319. Okay. Now this 11,484 is your LCM. Okay. Because now this 11,484 is divisible by 29, 87 and 319. Correct? Yes, guys. Yes. So this is how you find answers very easily. Okay. So we are going to go through one more example and then wrap this session, guys. Okay, just give me one last 2 minutes. I'll just finish it off. Okay, and so just give me 2 minutes. So this is it. Now in this example, what happens is, you are sure you guys already know. Okay, 319 and 1044, they don't get along very well. They don't divide. 319 doesn't divide 1044. You already know that. Okay, so initially I start with these two numbers. You know 290 is divisible by 29. So what will happen is, because 29 can divide 290, this 29 will merge with 290. Okay, so what I'll end up with something like this. Yes, 290 and 29 will merge, but those two things won't merge. Okay, now 290 cannot divide 319. 290 cannot divide 1044 also. Okay, if 290 was able to divide 1044, okay, I would have club 290 and 1044. Yes, you get that right. 290 cannot divide 1044. 290 cannot divide 319. So if you cannot divide it, you have to write it in its prime factorized form. Okay, if you write it in its prime factorized form, you will exactly know the reason why 219 and 319 all those stuff are not dividing 1044. Okay, so we'll have a look. So you guys know, you already know the reason why 319 is not dividing. Okay, the reason why 319 is not dividing 1044 is there is no 11 in 1044. What is the reason for 290 to not divide 1044? Look at this. 290 has a 5. Does 1044 have a 5? No, right? It is not. Okay. So you in this case you always take the largest number, guys. Try to make sure the smaller numbers divide the larger number. Okay. If you are able to do it, then the final value gives you the LCM. Okay. Now your final point is to make sure that 1044 has 11 and also 1044 has a 5. So it must have 11 and a 5. So what do you do? When I say it must have 11 and a 5, multiply it by 11 and a 5. Or in other words, multiply 1044 by 55. 1044 into 55 will give me 57420, which is the LCM of all these numbers. Okay. So finally, we have the final example where none of the numbers divide the other number. 319 doesn't divide 1044. 290 doesn't divide 1044. Okay. No number divides the other number. In this case, you have to prime factorize all the numbers. This is a very rare case. Okay. But still, this is easy. This method is easy. Learn to understand it this way, guys. Okay. Now tell me, okay, why is it that 319 is not dividing 1044? Because it doesn't have 11. Yes, this we've already seen. Yes. Now, why is it that 290 is not dividing 1044? Because it doesn't have a 5. Correct. Now, why is it that 203 is not dividing 1044? Because it doesn't have a 7. Okay, so if you pay close attention, it doesn't have a 7, 11 and a 5. 1044 doesn't have it. If it had it, it would have been divided by any one of these numbers or all these numbers, however you want to see it. So, if 1044 should be divided by all these numbers 319, 290 and 203, guys, it means this 1044 must have as 11, a 5, a 7. So this 1044, guys, must be divisible by, must be multiplied by 11, 5 and 7, which will give you this as the answer, which is the LCM now. Okay. Now, why do we say this is the LCM, guys? I'll just give you my final thoughts. Why do we say this as the LCM? This is the LCM because this is divisible by 319, 290 and 203. Correct? Why do we say 57420 is the LCM? Because this is divisible by all the three numbers. The rest of all the three numbers. Okay. So why do we say, and for that matter 1044 also. Okay. And why do we say 1044? Did you look at the first question? Why did we say 1044 is the LCM? Because it was divisible by all the four numbers. Here also 57420 is divisible by all the four numbers. Here also 40940 is divisible by all the four numbers. Okay. And you guys know LCM is the least multiple of all the numbers. Yes, you know that, right? Yes, so that is the case here. Okay, so I hope you got it. You have to practice, guys. Okay, so watch this lecture again and again and practice. When you have doubts, you make sure you ask me. Okay, when you have doubts, you make sure you ask me. Okay, so I think if you have any doubts, post it here, or else we'll wind up the session, guys. It is almost 1 or 10 minutes. So practice what I've taught you here. Okay, if you have doubts, we'll address it in the next session. Okay. So any doubts you have, guys? So did you understand it? Okay, yes sir, Palaniyappan, Ayanar, Sai Jyotesh, they all say they understood it. Okay, Jawahar, Santosh, Hefsiba, okay, Okay, guys. So hope you got something out of it. Okay, you can. It is always, you see, even if you have doubts, just go through that. Remember to go through that problem that I gave you. That window grills 12 meters, 8 meters. Okay, so we'll be discussing it in the next session. Okay, so next session we'll be doing it. I'll give you the exact explanation for it. You could come up with your own answer. I see most of you say you got it. Okay, so I think we should wrap up, guys. Okay, so work on this HCF and LCM, and if you have doubts, you can ask in the next session. Okay, okay, guys. So thank you for me. Thank you. So we'll meet on Friday.